Hello guys, welcome back to my channel. In our previous videos, we have learnt about RDBMS concepts, the three normalization forms, as well as the data types and operators in SQL, right? Today, in this video, we shall learn about the DDL commands in SQL. So, without any delay, let us get started. DDL stands for Data Definition Language. The set of commands in SQL used to create, modify and delete database structure are called DDL commands. Okay, we have different DDL commands. We shall see each of them one by one. Let's start with the create command. We can create a table, a view or a new database using the create command. Okay, here we have the syntax for creation of a database using create command. Firstly, use the create keyword, after that database, followed by the name of the database of your choice. But remember that any reserved keywords should not be used as the name of a database or any other object. Now let us create a sample database and see how this command works. Okay. Now let us create our database. I am having the database name to be testdb. Okay. So to create the database, firstly we have the syntax. We have the create keyword followed by the keyword database and which is followed by our database name. Okay. Now let us execute this query. Yeah, our database has been created. Now to check if this database has been added to our list of databases or not, let us use the command show databases. Okay, now let us execute this query. Yeah, here we have all the databases here, and yeah, our database testdb has been added to all the database list. Okay, now let us use this database. Now if you want to create any table within this database created by you, we have to use the command use followed by the database name. Okay, the use keyword followed by your database name. So let us execute this query. Yeah, now if you create any table or a view, that object is stored within this database testdb. Okay, this is how you create databases and use them to create your objects. Okay, now getting into the syntax for the table creation, we have create table followed by the table name, which is followed by a parenthesis within which we give a column names, which is followed by the data types. Okay, each column is followed by its respective data type. Okay, you can give the number of columns as you want, and you can also give the constraints while creating the table, which we'll discuss after creating the basic table. Okay, so let's start with the creation of a first table. Let us create a table. To create a table, firstly we have to use the create keyword, right? So I am using the create keyword table followed by the table name of your choice regarding the information, the data you are going to collect in your table. Okay, so I am using the name student here followed by open parenthesis. Now I want to have three columns in my table. First column to be ID space and then followed by the data type, right? So I want to use the data type int followed by a comma. Now the second column, the name of the second column, I want to use the name of the second column to be name, okay, followed by the data type varchar with the maximum value to be 50, okay. Now, sorry, maximum length to be 50, okay. Now, let us have my third column, age of data type int. Let us close our parenthesis. Now, semicolon. Let us execute this particular query. Yeah, our table has been created. To see our table format, let us select star from student, okay. This statement selects all our table. It shows the complete table, okay. Yeah, we got our table with 3 columns, ID, name and age. Until now, we haven't inserted any values into our table, so we do not show any values, okay. Let us insert the values after learning about the insert statement. Getting done with the create command, let us get into the drop command, okay. The drop command is used to delete a database or a database object like a table or a view within your database, okay. You can delete the complete database or a complete object. You will not have any traces of that object, okay. So now the syntax for the deletion of the database is that drop followed by database followed by your database name, okay. For deletion of the table, drop table followed by your table name, okay. It's as simple as that. Let us see with an example. Up to now, we have created a table named student and a database named testdb, right? So now, let us delete these two, the table and the database, okay? I'm using the drop command, drop table. Firstly, we are deleting the table, right? Because if we delete the database, the table even will get deleted. So, drop table followed by a table name which is student, okay. Now let us execute this query. Yeah, now we no more have our table student, okay. Let us see that. Select star from our table name, okay. Yeah, we got an error. Table testdb.student doesn't exist, right? As we have deleted the table, that table no more exists. Now let us drop our database testdb, okay. Drop database followed by our database name. Now let us execute this query. Yeah, our query has been executed. Now let us see if our database is present in our list of databases or not, okay. I am using the command show databases. Yeah, now execute this query. Yeah, we no longer have our database testdb in our list of databases, right? So this is how you use the drop command, okay. After the drop command, we have the truncate command in DDL. The truncate command is used to delete the components of the database object, okay. The only difference between the drop and the truncate command is that the drop command deletes the complete table along with its structure, okay. But while using truncate command, it deletes only the components of your table, that is the values present in your table, but the structure of the table remains the same, okay. So this is the difference between the truncate and the drop command, okay. The syntax for truncate command is truncate table followed by the name of your table. And next we have the alter and rename commands. Okay. The next command we get here is the alter command. Okay. The alter command is used to change the structure of your table which is pre-existing. Okay. If you want to change the structure of your existing table, we use the alter command. Okay. If you want to change your column name, or if you want to add a new column, if you want to provide constraint to the existing column, or any other operation, you use the alter command. Okay. The basic syntax for alter command is that firstly we use the alter keyword followed by table, which is followed by the table name, and at last we provide the operation to be performed for our alter command. Okay. Before getting into the examples of alter command, let us learn about constraints. Okay. So that we can also provide constraints to our tables. Okay. So let us get started with our constraints. Okay. Constraints are the rules given to the columns of a particular table. Okay. The constraints can be given while the creation of the table, or you can use the alter command to add or remove constraints to a particular column of a particular table. Okay. We have different constraints. Starting with not null constraint. The not null constraint makes sure that a column do not have any null value. Okay. That means while inserting the table, if you do not give any value for that particular column, the interpreter throws an error. Okay. So for any column which is given a not null constraint cannot have a null value. Okay. I have already said that a null value doesn't mean to be 0. Okay. A 0 is a particular value. Null value means not having any value. Okay. So let us see this with an example. Firstly, let us see how to use the not null constraint while creating the table. Okay. We already know how to create the table. We use the create keyword followed by the table and the table name, right? Here I'm going to use the sample table name table 1. Okay. Now I'm going to use only one column as it is just to demonstrate not null constraint, right? So I'm using the serial number to be the column name and int to be the data type of the column, and finally I'm giving the not null constraint to my column serial number. Okay. Not null. So here we have return our statement create table followed by table name, column name, data type and the constraint, right? Now let us run this query. Yeah, our table has been successfully created. Now let us see if this constraint works or not. For that we have to insert the values into the table, right? So let us insert into table name. Our table name is table 1 followed by the keyword values. Don't worry about the statement, we shall learn about this later clearly. Okay. Now I'm not giving any value. Now let us execute this query. Yeah, the interpreter has here thrown an error. So our not null constraint is working, right? Now let us use the alter statement to add the not null constraint to a column in any already created table. Okay. So firstly we have only column serial number here which already has the not null constraint. So firstly let us add another column into our table 1. For that we use the alter statement alter keyword followed by the table followed by the table name, which in our case is table 1. Now as we want to add the column into our table, let us use the add keyword, add, and followed by the column name, let us say age, followed by the data type of the column we are going to add. Okay, let us say int here. Okay, now let us execute the query. Yeah, now the column age has been added to our table 1. Now let us use the alter statement to add not null constraint to our column age. Okay, so alter table, again table 1. Now we want to modify a column age, right? We want to add a constraint. So we use the modify keyword, modify, followed by the column name, age, and the data type. And finally, we add not null constraint. Okay. So now let us execute the statement. Yeah, not null constraint has been added to our column age. Now let us see that by using the disk table command. Yeah, we got two columns here. Field, under field we have serial number, which is of type int, and null values are not allowed for serial number, right? And the second column age, type int, and null values are not allowed. So this is how we add the not null constraint using the alter table statement. Okay, and here we have also seen how to add a column into a table, into an already existing table, by using the alter statement. Okay, the next constraint after not null is that unique constraint. Okay, the unique constraint, by the name itself, it suggests that it makes sure that each and every record of a particular column which you have provided the unique constraint is different. Okay, that is, the each and every row is different for that particular column. Okay, if you give the same values for that column for any two rows, the interpreter will provide an error. Okay, so let us see it's working on our SQL workbench. Now let us create another table to see how to add a unique constraint to a particular column. Okay, while creation of the table. Okay, so create table 2. Let's say the column name to be id, followed by the data type int, and I want this column to be unique. Okay, yeah, now let us execute this query. Yeah, our table has been created with a column id, right? Now let us see. Yeah, we have field id type int, and as we have not given any not null constraint, yeah, it can take null values, and it is a unique. We have added the unique constraint to this particular field id in our table, right? Now let us see how to add the unique constraint while using the alter statement. Okay, for that let us add another column again, alter table 2, add. Now let us say salary, followed by the data type, let us say float. Okay, now let us execute this query. Yeah, we have our column float, right? Sorry, salary, right? Now let us add the unique constraint to this particular column, alter table 2, and we use the modify keyword, right? Modify, followed by the column name, followed by the data type, Remember that you can also change the data type of a state of a column using the alter statement, okay? Just you have to add the data type giving the column name, okay? Just as we give while creating the table. Okay? Now salary float followed by the constraint unique. Now let us execute this query. Yeah, our query has been executed. Now let us see our table description. Yeah, now we have the unique key constraint for the two columns ID and salary, right? So this is how you add unique constraint to a column while creating the table and using while using the alter statement, okay? Now let us see if this unique constraint is working or not. By using the insert statement, I'm inserting the values into my table, table 2, insert into table 2 followed by the keywords values. Now let us give the values for ID. I'm giving 1 as a value, and for salary let us say 20,000. Okay. Now let us execute this query. Yeah, our query has been executed. Now let us insert another record. Insert into table 2 values. Let us give the same value 1 and let us change for this. Yeah. Now let us execute this query. Yeah, it has given an error, duplicate entry 1 for key table 2 dot id, right? So for the column which is given the unique constraint will not take any duplicate values, okay? All the values must be unique. So this is how the unique constraint works. Now let us get into the next constraint, the primary key constraint. The primary key constraint is the combination of both unique and not null constraints, okay? So if you want a column to have all unique values and and the same column to have to do not have any null value for any particular record, then you can use the primary key constraint, okay? Now let us see how to use this while creation of our table. Now let us create another table. Create table followed by the table name, let's say table 3, followed by the parenthesis within which we contain all our column names along with the data types and constraints, right? Let us have three columns in this table. First column to be ID and of data type int, and the next column to be name of data type varchar. Let us have the maximum length to be 50, okay? Now third column to be salary. Let us say the data type to be float, okay? Now I want to add the primary key for the column ID, okay? Now I'm using the keyword primary key, open parenthesis, within which we have our attribute which we want to be the primary key. Remember that a table can have only one primary key, but that primary key can be a single attribute or a combination of two or more attributes, okay? Now let us end our create statement and let us execute this query. Yeah, our table has been created. Let us see. Yeah, we have three columns here. First column ID and second column name and third column field, right? So we have given the key to be primary key, right? Now let us see if this works or not. I am going to insert values into the table. Table 3, we use insert into table name followed by the keyword values followed by values to a particular attribute, right? 1, and I want my name to be some John and the salary. Okay. Now let us execute this query. Yeah, we have one row added into our table, right? Now let us execute another insert statement. Table 3 values. Let us say we again give the value 1 and the same name and the same salary. Yeah. Now let's execute this query. Yeah, we have got an error. Duplicate entry 1 for key table 3 dot primary. We have given the duplicate entries even for name as well as the salary, but it has not taken only for the column ID. Now let us have another insert statement. Insert into table 3 values. Let us say we have value 2 and let us have the column name to be same. Yeah. Now let us execute this query. Yeah, this statement has been added because the value ID is unique here, right? The value for that particular attribute ID, which is a primary key, is unique, and the interpreter does not care if the remaining values are unique or not. Now let us see our table. Select star from table 3, right? Now let's execute this query. Yeah, we got our table with two columns where the name and salary are same for two columns, but the ID is different. Similarly, you cannot give null values also to your attribute which is a primary key. Okay, so this is how a primary key works. Getting into the foreign key constraint. Foreign key constraint is used to maintain a relation between two tables. Okay, it references the primary key of another table. Okay, that means the foreign key of a particular table references the primary key of another table. Okay, that is the any member of the primary key of that table must be also the member of the foreign key attribute of this particular table. Okay, now let us see how this works. Let us create two tables, namely student and the course table. Okay, let us create the first table. Let this table has the primary key and the next table we shall reference the foreign key with this table. Okay, now create table student. Let us have the column name id int followed by the name which is another attribute of varchar data type. Okay, now let us give the primary key constraint to a column id. Okay, let us end the statement and execute this particular query. Yeah, our table student has been created. Now let us create another table, namely course. Let this has the column name id. You can have the same name or different name, it doesn't matter. Okay, and the course varchar. And now I want to give the foreign key constraint to the ID attribute which references the primary key of the table student. Okay. Now let us add foreign key constraint. Foreign key within parentheses we have our attribute which is the foreign key, and then we use the references keyword and then the table name in which you have the primary key which you want to reference with this foreign key. Okay, table name student and the column name is ID. Done. Now let us execute this statement. Yeah, we have two tables, student and course, right? And we have foreign key in our table course. Now let us see how the foreign key constraint works. Now let us insert the values into our table course, okay, which has the foreign key. Insert into our table name course followed by the values keyword, and then let us give the values. Yeah. Now let's execute this particular statement. Yeah. This has provided an error. Cannot add or update a child row. A foreign key constraint fails, right? Only the value which you have in the parent table, that is here the parent table is student, only that value you can have in your child table for that particular attribute which is a foreign key. Okay, now let us insert values into our student table first. Insert into followed by the table name, values, let us say 1, and name, let us give any sample name. Yeah, now let's execute this query. Yeah, our table, the values 1 and John have been inserted into a table student. Okay, now let us try to insert values into course. Okay, insert into course values 2, and then let us have 1. Okay, now let us execute this query. Yeah, now it has been inserted, right? So this is how a foreign key works. Only the value present for the referenced attribute in the parent table can be added to the child table. Okay, so here our child table is course and the parent table is student. Okay, the next one is the check constraint. This constraint makes sure that all the values under a particular column satisfies certain conditions. Okay, that is, if you provide check constraint with certain conditions to a particular column, then all the records of that column must match the conditions. If you provide any value without matching the conditions, then the interpreter will return an error message. Okay, so let us quickly check how this constraint works. Now let us demonstrate the check constraint using by creating another table. Let us create a table named table 4. Create table followed by the table name, and then I want 3 columns here: ID of data type int and name of data type varchar. Let us say the maximum characters to be 50, and after that we have the column age to which we want to provide the check constraint age of data type int. Now I want to add the check constraint to this particular column age. Okay, so I'm using the keyword check age greater than 18. Okay. Now let us execute this query. Yeah, our statement has been executed and a table 4 has been created. Now let us try to insert values into this particular table 4. Okay, insert into table 4 values. Let us say id 1 and then the name and finally the age. Let's say some 15. Yeah. Now let us execute this particular statement. Yeah, our interpreter has thrown an error. Check constraint table 4 check 1 is violated. Okay, as we have provided a check constraint and the condition for our age column is that age should be greater than 18. That is, each and every record under the age column should be greater than 18, even not equals to 18. Okay, so as 15 is absolutely less than 18, so the interpreter do not take that value for our age column under table 4. Okay, this is how you use all the statements. Now let us quickly see how to rename a column using an alter statement. Okay, we have seen how to add a column, we have seen how to add a constraint, but we have not seen how to rename a column, right? So now let us use the alter statement, alter table, and again the same, let us use our present table 4, alter table 4. Now I want to rename my columns, right? Rename column keyword, rename column, and firstly use your old column name, use the to keyword, and then you write the new column name. Okay, I want to change my column name id to serial number. Okay, now let us execute this query. Yeah, column name is being changed. Now let us see if it is changed or not. Yeah, here we got serial number, name and age. We do not have any column like id, right? We have given id as the column name while creation of table, but we have renamed it, so our column id has been changed to the column name serial number. Okay, this is how you rename columns using alter table. Okay, so we have learned about constraints, we have learned about create, drop, truncate and alter commands. So that's all about ddl commands. Thank you.